Alrighty, so here's a somewhat quick video on the BK667. It's a solid state tube tester. Does an excellent job for testing shorts and grid emission, and also does a pretty good test on actually testing the quality of a tube, and is it likely to work in circuit and so forth. So the big functionality aspects that most people buy these for, a tube tester like this, is the grid emission testing and short testing secondarily. But the grid emission is on par with the Syncor tube testers, and the reject area begins at 100 megohm, which is here on this scale, starting right there, and it goes from 100 megohm right there all the way down to 0 about. Now you might ask, well, why do you need something that good? And for audio amplifiers and so forth, grid emission is super important for the output tubes. You don't want an output tube to have any or hardly any grid emission, because grid emission or leakage results in excess DC current. The tube gets hotter, the tube starts to pull more DC current, and eventually the tube will just melt, short, blow up, or take out your output transformers or your power transformer. It's extremely bad. It will and can destroy your audio amplifier. So your output tubes should be tested regularly for that grid emission. And let's go ahead and do a quick test of a tube right now. So let's see. The sort of test we're going to show is first the grid emission test. So if you look at the manual for this thing, it says to put 100 megohm across pins 1 and 9 of socket 6 and put the selector to 1. So there's your 100 megohm resistor, and we can have this selector at 1, and you can press leakage, and we should see that move, and there you go. So it moves right up into the grid emission reject area, and that's a 100 megohm resistor. We can test for shorts in the same way. For shorts, put it between 1 and 9, and at 1 position on the selector, the lights go glowing, and that's a 750 megohm resistor. And if you go over to 9, 7, 8, 9, you see it glowing again. So that shows you that those two circuits are working. And if you wanted to test some tubes, you take that out and put in a tube. Here's a 6v6. I test strong on a few different testers. So 6v6, the chart data says D1 and B5. Put that to D socket 1, and that's backwards. This is supposed to be a D, which it is. D1, B5. Okay, so now we got that correct. Double check this, and there's no lockouts pressed. This is at D. That's for the filament voltage, the heater. Plug this guy into there. And then the tube's warming up. You should let output tubes warm up for probably close to a minute. The bigger the tube, the longer they take to heat up. So let's see. You can rotate for shorts. Checking this light. Flashing is okay, just as long as it goes out. Flash on 3, back to 5. So no shorts per se. We can check for leakage here. And there's no movement there, so that's saying there's hardly any leakage. Press for quality. Quality is strong, around 105. You can go back and check for leakage again. Nothing there. So the way that this tester does, and most emission testers do, or many emission testers do, is they will put a voltage and connect it to the grid of the tube, and then at the cathode of the tube they will measure the current coming off the cathode that's flowing through the grid and ending up at the cathode. So that's what these do. What it's basically doing is it's checking for the amount of current emission that the heater and cathode coating provides. And it's a pretty good way of testing a tube. It's totally different than the testing for GM, or the amount that the tube can amplify, but for the most part it can work pretty well. Okay, so this guy is all tested. We can pull him out. Now if you're saying that doesn't sound right, well, okay, check this out. This is a 6BQ6 GTB that has a plate cap. So that's the only connection to the plate. So it goes in 1. 6BQ6 is E1, socket 1, A5. So we're not going to hook up to the plate. It doesn't say to or anything. So we can check for shorts. Back there, check for leakage. No leakage. Check for quality. And we're at 100. So there's nothing hooked to the plate, so you know it's not going to the plate, it's going to the grid. And that's how that's working. Like I said, an emission testers mostly, well, they, as far as quality go, they're only checking to see if the emission is strong enough to work in circuit. So let's see. Okay, so the main reason why you want to have these things, as I said, is to check for grid leakage. So here's a 6W6 that is a tube with a ridiculous amount of grid leakage. And what you'll notice about tubes that have a lot of grid leakage is that they will be hotter to the touch than the other tubes after a minute or so of cooling down. That's because all that DC current in the tube is just getting very hot. So let's see, the chart numbers for this guy are E1C5. So we got it on E, socket 1, C, and then 5. So let's go ahead and plug this guy back on. That's E1C5. So we can check for shorts. The tube's heating up. Should let this This stay longer, but we can do a quick check for shorts. I've checked this guy several times and I don't see a short usually. So that's done. Now leakage. Let's see if that's starting to show any leakage yet. And so far it's not. Is the tube a little warm? No, it's not very warm either. Okay, so we can check for quality. Quality is 110, so that's plenty there. Tube is not warm much yet. So let's go ahead and do another. Okay. Tube is getting warmer now. Let's check this again. Oh, now it's starting to take off. See, so when you are doing this sort of test with output tubes, you want to be patient and leave them in for a minute or two, just so you have enough time for the tube to actually get hot enough. So it's way into the grid emission reject area. And at this point, the tube is quite hot. Well, it's very, very warm, and back there it's like you don't want to hold it any longer. And it's just getting worse. So being able to test your output tubes for that grid emission, that's very important if you've got an audio amplifier with the tubes and so forth. Yep. Okay. So let me pull that hot. That's hot. Okay. So if you were going to rebuild one of these, well, you want to first check out and see what's working, kind of like what I was doing with the grid emission tests and the 100 megohm and shorts test and so forth. And so going back through what do these different controls do, the selector will route the correct voltage, will route the voltage to the grid. The load control, it routes the correct voltage over to the selector, and it also connects up the proper load to the cathode of the tube being tested. So in doing that, you see it's got these different loads: A, B, C, D, F, G, H, J. So when it's at A, it is connecting this 140 ohm resistor. This end is the ground side of the power transformer, and as well as ground side of the capacitors here. And this side here gets routed over to that switch. Go over to this load selector, and then it gets connected up to the cathode. Actually, this side doesn't go over to that switch. It just it goes from here over to the cathode. So when it's at A, it's only this guy, this resistor, about 140 ohms, and then when it's at B, it's 140 plus this one over here, the 160, and so forth, going around. Now, on tube sound, he very carefully tells you which voltages and so forth, which you can see for setting up a 6L6 and going to socket 1 and measuring the voltage and resistance from the cathode over to the grid, like that. And we can do the same thing. So, like right here, turn this guy on. And so when we're not pressing any buttons, it's about 100 volts between the pins to check for shorts. When you check for quality in position A, get about 43 volts, and same thing there, and so forth, going around. And that comes from the schematic as the info shows you. Now for testing actual resistances, we'll unplug the thing, and if we put this guy to resistance and just check the quality, like right here, he'll say it's supposed to come out to be about 140, and you might wonder, why is that a little bit higher, 163? And the reason it's higher is because these two probes are going from pin 8 to 5. And at 5, you know, what is the resistance between pin 5 and 8? Well, 5 goes here, goes over to the power transformer, through the power transformer, through the ground, and then it goes through this resistor, this 140 ohm resistor, and then to here. So this extra amount of resistance you're seeing is the impedance of the transformer. So that's why it's slightly higher. And depending on what tap you're on, that's going to change. So if you, as long as you're cognizant of that, then you'll be able to see what's what. So what we can do is, if you wanted to, you could just check from 8 to ground. So the ground side is here on that side, that end of the resistor. We can put this side right there. So now we're on the ground side of the resistor, and then we can look at the cathode. And I'll put that back on. Cathode right there. Yeah. Okay, so then you get back here to 1, 2, 3, 4, 5, 7, 8. There's that. So right there you're seeing 139 ohms, or real close to 140. And then you go to step B, and now we're real close to 300, which is the 140 plus 160. You see another 300 and so forth. So that shows you why the values are a little off, and it's just reading the impedance of the power transformer. The simplest way to measure those resistances is to just take it out of the chassis and put the ohmmeter across those resistors, the big 140 and those. And you can compare them to the schematic and so forth. But there it is. It's a real good tester. excellent for checking out the grid emission leakage of your tubes, and highly recommended. Thanks for watching. Catch you later.